we are going to talk about the interior angles of a polygon, and mostly the sum of the interior angles in a polygon. So first of all, we're going to start off with triangle. Okay, if you got a triangle, you know that all the angles in a triangle add up to 180, right? Okay, now what if I have any quadrilateral? Well, you can, from one point here, I could draw a diagonal, and I know that these two triangles add up to 180. The angles in here add up to 180, the angles in here add up to 180, and if I add those together, I know that all the angles in here are going to add up to 360. And you did this in today's activity on Desmos. Now, what if I want to find out the measurement of all the angles together of a pentagon? Well, from one point, I can divide a pentagon into 3 triangles. The angles in this triangle add up to 180. The angles in this triangle add up to 180. And same thing here, add up to 180. So to figure out the sum of all the angles in a pentagon, I can multiply 180 times 3, and I get 540. Okay. So what if we got a hexagon? Okay, so once again, I know I can divide it up into 180, 180, 180, 180. From one point, I could divide it up into 4 triangles, and so if I multiply 4 times 180, all the angles inside the hexagon are going to add up to 720. Okay, so what if I got a 7-sided shape, which is called a heptagon? Then, once again, I could divide it into 1 triangle, 2 triangles, 3 triangles, 4 triangles. 1, 2, 4, 5 triangles, right? So we got 5 triangles. 5 times 180 gives me 900. Okay, so there's a pattern. Let's talk about this pattern and figure out a formula. Okay, so when I had my single triangle, there were no diagonals, and the degrees added up to 180. Okay, so if I had a 4-sided shape, I had 1 diagonal, and there were 2 triangles, and then we knew that the total degrees was 360 of all the angles inside the quadrilateral added together. Right, I could do an example. You know, if I've got a square, this is 90, 90, 90, 90, and 4 times 90 is 360, right? The sum of the interior angles. Okay, now a 5-sided shape, which is a pentagon, we said that we could draw 2 diagonals, and it gave us 3 triangles on the pentagon. So here's a pentagon with 3 triangles, and we said that the sum of the pentagon of the interior angles is 540. And with the hexagon, we said that we could draw 3 diagonals, right? So 3 diagonals, that's the red lines, right? And it made it into 4 triangles. And the sum of the angles, we said, was 720. Okay, and then the 7-sided shape, we said had 5 diagonals, and oh, something happened here. Oh, no. The 7-sided shape, my mistake. 1, 2, 3, 4 had 4 diagonals. Whew, almost made a mistake there. And we were able to break it up into 5 triangles. And the 5 triangles added together gave me 900. Okay. All right. So what is the pattern? So if I've got n number of sides, then how many diagonals am I going to be able to draw? Okay, this is always 3 less than this, right? So n minus 3. So the number of triangles, this is the important thing, the number of triangles is, this is 2 less than the number of sides, right? If I've got 7 sides, I've got 5 triangles. So I've got n sides, I have 2 less, right? This is 2 less than that. This is 2 less than that. This is 2 less than that. 5 triangles is 2 less than 7, right? So if I've got 100 sides, I'm going to break it into 98 triangles, 2 less than that. And so to get the total number of degrees, it's 180 times n minus 2. And that will give me the formula to find the total number of degrees for any polygon. Now, what if it's a regular polygon? What's the measurement of a single interior angle if it's regular? Regular means all the sides are the same length. Okay, well, if I've got an equilateral triangle, you have seen those before, these angles are all the same, so 180 divided by 3 is going to give me 60, right? Okay, if I've got a square, I could do 360 divided by 4, and I'm going to get, I know that each angle here is 90, right? Okay, 5-sided shape. I could do 540, the sum of the angles divided by 5, and what am I going to get? So 540 divided by 5, and I'm going to get 108 degrees. So if I've got my pentagon, and each of those angles is going to be 108 degrees. Okay, now if I've got a hexagon, you've seen a lot of those, so I can do 720 divided by 6, and that's going to give me 120 degrees. So as you already know, so these angles here are all going to add up to 120 degrees. And you can see they're obtuse angles, so it should be something like that. So 900. So the total number of degrees of the heptagon was 900 degrees, right? All of these angles together add up to 900 degrees. So what is the measurement of a single angle? If this is a regular shape, I could do 900 divided by 7, and it's approximately 128.6 degrees. Okay, so what if I have n number of sides? Then what I'm going to do is I'm going to have this value divided by n. So 180 times n minus 2, and all of that divided by this value, which is n. And that's going to give me the measurement of each interior angle. So maybe let's just write that down. So the measure of each interior angle of regular polygon is equal to 180 times n minus 2 over n. Okay. And on the previous page, let's write this out here too. So the sum of the interior angles equals 180 times n minus 2. These are the two formulas you're going to be using in the assignment. That one, and if you want to find the measure of a single angle in the interior of a regular polygon, you'll use this formula here. Okay? You may want to watch these notes a few times if you need extra help.